Hi, this is Mrs. Vrobel. This is part one of chemical reactions. So as you see on the first slide here, I have a match, and I want to show you, this is an example of a chemical reaction. So what's happening here is you actually have red phosphor, and I'm striking on the side of the box, and this is actually crushed glass, which gives it enough friction so that when you strike it, it interacts with the sulfur and the potassium chlorate that's part of the match. So here is an example of a chemical reaction. Now it's important to remember when we're looking at chemical reactions that we have to remember the conservation of mass. So we can't get a free lunch. It's neither created nor destroyed. So what happens is whatever mass we start with changes into something else, and we have to keep track of all of the masses. Okay, so you may have heard of and you may have seen what we call a chemical reaction or a chemical equation. And always the reacting substances are on the left, the products are on the right. And there's an arrow that typically goes from left to right. Now you may see a situation, just to let you know this is possible, you may see a double arrow. So what that means is the reaction can go to the right or it can go to the left, depending on what you have. The plus symbol tells you you have more than one substance. You may see these symbols at the bottom here. So S is solid, L is liquid, G is gas, and AQ is a water solution. We'll be doing a lot of reactions with water solutions. Okay, so you may begin given a written equation and you have to translate it into the nomenclature or the shorthand that chemists use. So notice here it says aluminum S, so S stands for solid, and you may see L, L stands for liquid, and then the equation would be aluminum and bromine react to produce aluminum bromide. We use what we call skeletal equations. Chemists are lazy, they don't want to necessarily write everything down, and they use the symbols and the formulas. So notice that these are the two reactants. Here's the product. This is essentially solid aluminum reacting with liquid bromine to give us aluminum bromide. Notice I'm not saying aluminum tribromide, okay? This is an ionic compound. We do not use prefixes with it. Okay. Why do we do this? We need to keep the conservation of mass. The question is it balanced? It's very important when we're looking at chemical equations whether or not something is balanced. Now notice, if you look at the diagram here, we have one aluminum atom, we have two bromine, and we're ending up with 3. So the question is this a balanced chemical reaction? The answer is no. Now, we're forming the correct substances, but we don't have the correct amounts. So we need to show a balanced equation, and the way we do that is we put what we call coefficients, and they are right in front of the element or compound symbols. So in order to make sure that the mass balances, notice we have 2 aluminum atoms in the reactant side, we have 2 aluminum atoms in the product side. Here we have 3 sets of bromine molecules, or 6 bromine atoms. Here we end up with 6 bromine atoms, 3 in each product. So you have to have a balanced equation in order to have a true chemical reaction. Okay, how do we do it? Well, the first thing is you have to translate words into symbols. So you may be given a chemical formula, or you may be given the written name, and you have to be able to translate both. please, please, please make sure you remember your nomenclature. Ionic compounds are named differently than covalent compounds, so we have to keep both straight. And then lastly, we need to look at coefficients. So coefficients are used in order to balance equations. That means we have to keep track of the same number of atoms on one side as we see on the other. Okay, so here we go. We have a chemical equation where we have natural gas, which is in the formula CH4, burns in air. Whenever you see the term air, just assume they mean oxygen. So even though air is composed of even though air is composed of more than just oxygen, we typically just look at it as oxygen. And notice it's producing carbon dioxide and water. So we're talking about CO2 and H2O. And once we've identified things, we have to conserve. We have to figure out what is the coefficient of each going to be. And in order to do that, we're actually looking at what we call mole ratios. Now let me just show you here. For the chemical equation, if we write CH4 plus O2 yields, or reacts, gives us CO2 plus H2O. The question is, do we have the right number? Here we have one carbon, one carbon. We have 4 hydrogen here. We only have 2 here, so it's not balanced. Same, we have 2 oxygen here. We only have 1 here. Okay, so you have to figure out a way to balance the equation. I'm going to show you that in the next example. Okay, here we go. So calcium reacts with water, produce calcium hydroxide and hydrogen gas. Now I'm just going to go through these next 3. And I want to start on my blank page here. Okay, so the first thing you want to write down are the reactants. So we have calcium. Now I'm going to make it a solid because that's typically how calcium is in the natural state. If it's reacting in water, I'm going to list water, which is H2O. I'm going to put a L in parentheses to symbolize liquid water. That means it's a pure substance. Now, here you have to transfer calcium hydroxide. Calcium is the cation. This is an ionic compound. Hydroxide is OH. And I'm putting this in parentheses because I need to look at the charges of both. Calcium, let's go to our handy-dandy periodic table. Calcium is listed in the second column here. It is a 2+ charge. So let's go back. I have to rewrite this because it forgot all my information. Okay, so if calcium hydroxide is a 2+ charge, let me just rewrite this. Calcium solid plus H2O liquid yields. Now I'm not putting a subscript by calcium, and I'll tell you why. The hydroxide ion is a -1. This is a 2+. So I'm going to do crisscross. I'm going to put the subscript of 2 down there. Now this is aqueous, so it's AQ plus hydrogen. Hydrogen is diatomic, okay? So it's always going to be H2 and then gas. Now, how do I figure out how to balance this? I do a little tally here. So R for product, R for reactant, P for product. So I'm going to list out calcium. Okay, there's 1 on this side, there's 1 on the right-hand side. Hydrogen, I have 2 on the left because of the subscript. I have 2 on the right because of the diatomic. And then oxygen, I have 1 here. Oh, I'm sorry. You didn't catch me. I have a boo-boo here. Okay, there's 2 hydrogen here and there's 2 there. So actually I have 4 hydrogen. I should write a 4 there. And then oxygen, I have 2 because of the subscript. Okay. So notice that calcium is okay. There's 1-to-1 relationship, but there's a 2-to-4 relationship here, and there's a 1-to-2 relationship here. So I'm going to put a coefficient in front of water, and what that does is it changes this 2 to a 4 and this to a 2. So this is the balanced equation. You don't have to do anything else. The number of atoms of the reactant equal the number of atoms in the product. Now let's go to problem number 2. Okay, so problem number 2, they're telling us we have water, but in that water is hydrochloric acid and sodium carbonate. And those two together are going to produce sodium chloride, water, and carbon dioxide. Okay. So let's go to my next here. Okay, how do I start? Well, I'm going to assume that the water is not part of the main reaction, that it's just part of the hydrochloric acid. Now, and I suggest making space in front of each compound just so you can put coefficients in front of it. The charge on sodium is a 1+. So I'm not going to put parentheses around CO3. The charge on carbonate is a 2-. So I'm going to put a subscript of 2 there for sodium carbonate. And that yields, we have salt, which is NaCl. It's going to be aqueous because it's in water, plus H2O. You can put L because it'll be a liquid form. And then CO2. If you didn't know, CO2 is a gas. Okay, so I'm going to do my tally here. I'm going to have reactant on one side, product on the other. And I'm going to count up hydrogen. Okay, there's 1 hydrogen on this side. There's 2 on the other side because of H2O. Chlorine. There's 1 on this side. There's 1 on the product side. The next is sodium. I have an Na. There's a 2 on this side. There's only 1 sodium in NaCl. And then carbon. There's 1 carbon, 1 carbon. Now for oxygen, I have 3 on this side. Now you have to be careful, because I did the mistake that you might do here. I have 2 oxygen and carbon dioxide. I have 1 in water. So I actually do have 3 oxygen on the other side. Now notice I have an imbalance between hydrogen and chlorine. So the question is, how am I going to balance it? Well, I can do it one of 2 ways. I think what I'm going to do is I'm going to start here and I'm just going to put a 2 in front of HCl. So that makes that 2 and it balances things out. And now I have 2 chlorine on the reactant side. So for the product side, I'm going to have to put a 2 in front of sodium. So hopefully that balances out the sodium, and guess what? It also balances out the chlorine. So just putting 2 in front of HCl and NaCl helps to balance out the overall equation. Okay, you are going to do 3 and 4 on your own, and just to help you out, white phosphorus is P4, and phosphoric acid is H3PO4. So the other ones, you should be able to figure out what those are by the names. And don't be surprised to see that with the video assessment.